All right, so in this real-world application, we see that biologists use the following formula to find the number of cricket chirps per minute. So N represents the number of cricket chirps, and that's based on the ambient temperature in degrees Fahrenheit, which is represented by capital F. We want to solve this equation for F. All right, so we had N equals 4F, capital F, minus 156. We want to solve this for F. So the first thing I'm going to do is add 156 to both sides. So I have N plus 156 equals 4 times capital F. Now I'm going to divide both sides by 4. All right, so I got, and I'm going to write this in multiple ways, all right? I could have F equals N plus 156 divided by 4. I could have F equals 1/4 times the quantity N plus 156. Or I could have F equals 1/4 N plus 156 times a fourth, or also 156 divided by 4, which is 39. All these I would accept as an answer. So all those are different representations of solving this literal equation for F. All right, but we're not quite done. We're going to take it a step further now because I'm telling you that the number of chirps is 120 per minute. And we're trying to figure out what is the ambient temperature. So instead of going back and plugging 120 in for N and solving for F this way, which we do know how to do, we know how to solve that. Instead of doing that, let's use our literal equation. Let's use one of our literal equations that we rearranged for F in order to solve for this. So like if I use the top one, I can say F equals, and I know the number of chirps is 120, then I just take plus 156 and I divide that entire numerator by 4. If I use my handy dandy calculator to do this quickly, I will figure out that the Fahrenheit is 69 degrees. So the ambient temperature that would result in 120 chirps per minute from these crickets is 69 degrees Fahrenheit. All right, so that's why we use literal equations, some word problem examples. Have a good one.